here we are with the third part of our 4-part Molt series, and we're going to focus on life history scheduling and how Molt fits into that. So let's go here to the, whoops. Going? Yeah, I think this is right. So in a constant environment, just in terms of scheduling your life, if you're in a constant environment, there's no better time to do anything. So you might as well just do what you need to do. You could just breed the whole year round, raise offspring, and then start over again. But as we pointed out, then your eventually your feathers wear out, so you need to incorporate something. And so as soon as you have to incorporate molting, you might concentrate your breeding in a certain part of the year, maybe a seasonal environment where breeding is a bit more likely to be successful, where you can use your territory to extract extra food for the breeding season. And so then you've got the breeding season, and basically the rest of the year is non-breeding, and you realize, oh, that leaves some time for you to schedule your molt at a particular time. Now, you might think breeding occurs at the time when there's most food available, but if you think about it, breeding actually coincides when food starts becoming available in large amounts. But really, the most food is available in August and September in our temperate zone. However, that molting. But if you're a migratory species, you might have to drop in a migration before breeding and after breeding so that you get to an area where you can feed in the winter. We talked about that a little bit, the contrast between insect eaters that need to be able to access insects during the season without plenty, the constraining season. So that might require going south where the insects don't all die in the winter. But if you migrate one way, you kind of have to migrate the other way. So that requires 2 seasons of migration. And then you could insert your molt here. That's 4 to 6 weeks. And here, if you think about it, you've got the greatest variety of food on available. You've got insects in profusion, large and small. Small insects tend to mature fastest. So here you've got, in the beginning of the season, you've got small insects, caterpillars just growing. And then by here, you've got dragonflies and deer flies and all kinds of large larvae, all kinds of options to eat. Fruits are ripe, seeds are ripening up. So there's a great variety of foods available for this time. So that's one strategy. You could put in the molt there. This is one way to capture that. If you just use the colors to think about molt scheduling or life history scheduling the course of the year. So you've got migration in purple, breeding in yellow, and molt in red. We were just talking about black-headed grosbeak, so that's a different way to schedule your molt. You could put it kind of after the migration on the place where you go to winter. So that would be another strategy in terms of life history scheduling that evolution could foist on your ecology. So that's one option. Or you could even molt in the spring. So there's different ways to structure this, and you can see that each of these strategies would create variations in when feathers are fresh and in specifics of the timing of each of these other patterns. So there's different ways to structure that. These are some of there's another pattern you can see early in the year, molt after breeding. And in fact, there's a pattern where you molt during migration. Really, you interrupt migration, you go only halfway. You molt go to the Mexican monsoon area in northern Mexico in the desert where the rain falls in August and September, migrate there, and then continue on to your winter grounds. So there's little mixes of these strategies as well. And so that could be a third strategy illustrated like that. So this relates to a project I was doing with birds in North America and South America, migrants in North America versus the migratory system in Europe and Africa, and comparing the different strategies that birds use in those different continental systems. We're finding that African trans-Saharan migrants that go all the way south to below the equator in Africa, they tend to use this strategy, whereas European and American residents generally use this strategy, and Western US migrants use this strategy right here. So you can start seeing that this opens up questions about ecology. Why is one strategy better than the other? And so now I'm going to tell you this narrative about what happens with our Western songbirds right here in Washington, and why we have residents that use this strategy and a lot of migrants that use this strategy. So that's what this will think about now. I already showed you what studying this work using black-headed grosbeak skins might look like. And here's a map that I can come up with that shows what they're doing. So the little dots represent all those specimens that I was showing you for adults, what the adults are doing. And the distribution of all these triangles is across the breeding distribution, right up here into Canada, which is this shaded area. So the specimens the collections we accessed used specimens representing all the breeding area here shown. And we could see some body molt initiating on those birds. If you look right here, these black triangles, 1, 2, 3, 4, and then quite a few down here, 1, 2, 3, there were about 12. Those were and here, those were the few birds that I was showing in the slide with the specimens in that graph that were actually molting flight feathers. So body molt starts occurring in many places, but the flight feather molt is restricted not across the range, but just to this area down here. Here we see the breeding range, the winter range is the cross-hatched area, this area down here. And that's where you see a lot of the flight feathers molting as well, right in there. And all the fresh birds in fresh plumage that have just replaced all their worn out feathers. And the gray area marks the area that's affected by this feature of the southwestern deserts, where all the rainfall falls, or 60% of the rainfall falls in August and September, July, August, and September, and concentrates all the rainfall in this area. So the point is, the black-headed grosbeaks vacate much of their northern breeding range in order to molt down here, whereas most of the eastern migrant birds, like rose-breasted grosbeak and a whole bunch of others, they molt right on their breeding grounds before they migrate. So that's a major feature of these western birds. And here's the way we interpreted that. So in winter, our area gets a lot of rain, but in summer, our area is quite dry. This mountain area, you can see that the east retains much more moisture in the summer. They get all those thunderstorms, whereas in the west, we just dry out. Doesn't seem like it this year. We're getting a lot of rain into June, but that'll stop shortly. And then July and August and September are likely to be pretty dry. And with that drying, this area experiences a rapid loss of primary productivity as well as insects. So they all go into estivation and make it hard for birds to subsist there. At the same time, what happens down here in the Mexican area is, you can see in this graph, here's January, February through December. Here's the rainfall pattern. In July, June, but especially July, August, and September, this area, this Mexican desert area, gets a sudden burst of rain. Storm also has storms because the sun is in the northern hemisphere and heating up the water around here in the Gulf of Mexico and the Gulf of California and the Pacific Ocean, heating up this water, a lot of moisture in the air, and that rains off in these storms that occur in mainly July, August, and September. That makes this whole area quite lush and green that otherwise looks like a dry desert, much like our area does. This is Washington in August, late summer. So if you're a bird, tough place to find food. Down here, a lot of insects. And so this is what we found. We found in the east, in this area, birds with ranges in this area, they 50 of 55 species stayed on the breeding range to molt, and only 5 moved, molted on or near their winter grounds. Whereas in the west, 50% of the songbirds that migrate stayed on the breeding grounds to molt, whereas the other 50% moved south into this Mexican monsoon to take advantage of that flush of vegetation and secondary productivity in the insects. So very strong contrast between those two life history scheduling features, and we see attendant speciation in those groups. So I might be having some challenge here. Hang on. Jenny? All right, I think I'm back. I had a problem with the PowerPoint. It froze on me, so hopefully there wasn't too much distraction there. Let's go here so we can continue. There we go. Okay, so I just want to go through a couple of examples like the black-headed grosbeak and think about the eastern corresponding species, just like we did with rose-breasted grosbeak. So here's lazuli bunting, also work that was done, similar results to the black-headed grosbeak. Turns out their breeding ranges up here. They don't have any breeders down in Mexico. And in their case, all the molting birds showed up here in Baja, southern Arizona, as well as some in this Sonoran desert area down here. And then they proceeded from there down to their wintering range. These specimen analyses showed. So a very similar situation. They're escaping this drying out of this what we call Mediterranean climate zone to go to where the food is at that time of year. Think about indigo buntings. They're the eastern version of that, all blue. They stay up on their breeding grounds and complete their molt before they migrate down to your Central America area. So a very different ecological pattern. Here's the data actually showing what's going on. Worn plumage throughout the breeding range, even down here into areas where they're migrating through, good numbers there. Fresh plumage though, hardly any of it occurs up here in the breeding grounds. See that? All the fresh plumage birds are down here toward their wintering range, a few right here in Arizona too. And the adults that are actually molting are split up a bit between these areas. Look, there are a few stragglers here that get started first. So there seems to be some variation in that strategy, but most of the molting birds really are in these Sonoran desert areas. Same thing with Western Tanager. Here's the breeding adults, hardly any breeders down into Mexico, all across the Western US and up into Canada. The molting birds are distributed way down here, south of most of the breeding range, with just a few initiating body molt up in here. But you can see these in the Sonoran range. That's in the winter range, not in the breeding range. And the eastern counterpart, scarlet tanager, molts right on its breeding grounds. So before it migrates, different strategy, different species. The project that Allison and I were going to take up again this summer with a field class we were offering was going to springboard off some work I did for 10 seasons with high school students up in the Cascades. So this is Mount Rainier. Yakima is down here. This is Natchez, Tieton. Am I looking at this right? Yeah, Yakima is right here. Here's Route 12. So it's north and south of Route 12. The elevation here, it varies from about 3,100 to White Pass, which is at 4,500. Here we've got a site, Cache Prairie, up at 6,000 feet. So a few sites. This was going to be our camping site. McDaniel Lake would have been great, but for social distancing, here's what that looks like from a nearby peak, McDaniel Lake. So you can see that it's kind of dry around there. So this is already August. And the idea is to look at what happens to these birds, the 13 species that don't migrate south. So some of them are leaving and molting in the southern area, but we saw that 13 of the birds of these migrants stay up here and breed. So how do they deal if we're saying that they're being driven out, that some of these birds are adapting a strategy that takes them away from this area in the dry season? How are birds that are sticking around and seem to molt up here, how are they dealing with it? So that's what our work focused on up here, and that's what we would have done some more of this season, and maybe we'll be able to do that when social distancing isn't necessary anymore. So McDaniel Lake is down at 3,500. In August already, you can see that the water itself defines kind of the primary productivity, this little basin, and that's where some greenery is still to be seen. Up at 6,000 feet around the same date, you can see that it's still quite lush. And so examining how this works up here is what the goal of this project was. So we've set up nets in these wetland areas. Here's one, that's McDaniel Lake, that's a back marsh of it, and there's these willows, and we would set up these nets in these willows, and this is what it sometimes looked like when we got to the nets. 27 birds in this net at once. So very high density between these alders and these willows of birds just flitting about in here in late July and early August. A lot of warblers, some sparrows, and this is what it looks like when you're inside the willows, very dark because the vegetation is well developed. Here's an orange-crowned warbler, one of the birds involved in this study that we would catch a lot of right in the middle of these little willow patches, surrounded by forest that's already quite dried out. You can see we're seeing the foreground right here. Here's a slope that isn't close to the water, isn't down in the water basin, and it's already quite dry. It's only right down in the water where you still get some moisture. And so here's a table. I know it's a little tedious to look at, but I just want to show what it was we found. So here's the number of individuals we caught for each of these species, including quite a few warblers. Look at that, orange crown, Nashville, orange crown, Townsend's yellow, Audubon's, McGillivray's warblers, a few sparrows, hermit thrush up there. The number of adults we were catching, the percent that were molting, So quite variable from chipping sparrow, just a few molting among the adults, to among orange-crowned warblers, 90%, 91%. So molting seemed to be a big activity. And in particular, the birds we would catch more than once, basically 100% of them were molting. So we were sampling some of these birds right at the site where they were proceeding to replace their feathers. So they were using that site to replace their feathers. Now, if you break it up by elevation, you see this interesting pattern. Here, these are the sites above 4,500 feet, above 4,500 feet. Pretty much all the birds we were catching there were molting. None of the birds we caught up there, except for a chipping sparrow, which looks like some kind of freak, and Oregon junco among the adults, all of those birds up there were using that site to molt. And the variation occurred on the sites below that. Here, Nashville warbler, we just didn't catch any birds up high. Same with McGillivray's warbler, we didn't catch any birds, any adults up at that higher elevation. They were all down low. And so that's why 100%, and so a lot of those birds weren't actually molting. So you can see down below, we get a variety of birds probably moving through. Even those that stick around though, they're molting. But up high, everyone up there is molting. That's what they're doing up there. And so schematically, I want to illustrate how this works out to favor these birds that stay here to molt. Those were all species that stay in Washington to molt and don't migrate south to molt, like the molt migrants that we talked about already. So we're going to look at a couple. We're going to make this a schematic to see what happens. So here's a spring shot of these Cascade Mountains. You can see what happens. Spring starts down here and it creeps up the mountainside, right? It goes from all white. In winter, this would be all snowy, and then spring starts thawing from the bottom up and creeps up the mountain. And this is kind of where spring is still happening. Wherever that line is moving, where the snow still occurs, where it hasn't thawed yet, that's where spring is moving up the mountain. So you can imagine schematically, if we just look at this mountainside, this one slope, we can start in May, when all of that would be snowy. And then if we trace through what happens through the rest of the summer, we would start with some thawing down in the valleys. That thaw creeps up the mountain slope, and by July, it's where we saw. And then in August, it's still creeping up to the top. And shortly after it greens up, it already starts drying out. So it's an ephemeral pattern of greening, primary productivity, insect deployment. The flowers are all blooming, and then it dries out and becomes much less productive. So here's that same prairie, so-called prairie we see up at 6,500 feet. This is on the 2nd of August, 2009. And you can see on the 2nd of August, everything is still quite green. It's still quite productive, whereas Lake McDaniel is already dried out. And here, just 19 days later, is the same meadow, slightly different view, but it's the exact same meadow, and everything is dried out completely in just those 19 days. So if you're in bird here, productivity is you can still find a bunch of insects here, and here you think about those mosquito larvae and everything else, all the other insects you might be going after, adult flies, mayflies, all that stuff is much less available once that starts drying out. Plants are going to seed, so if you're a seed eater, like a chipping sparrow, that might still be a suitable option. So here's just what happens in 9 days. We took some soil moisture measurements at 3,400 feet and at 7 sites, and we just compared what happened in the same place with a kind of soil, just a soil moisture meter down at 3,400 feet around Lake McDaniel. And at the 14th of August, there there were already some dry sites, but it was pretty variable from 10 to 90%. By 9 days later, the soil moisture had declined to no more than 45% at any site. So a much more drying pattern. High numbers here. Look, one site actually went slightly wetter. I can't explain that. I don't know what happened there. Maybe the cattle peed or something. So if you imagine representing this schematically, you could think of these wetland sites, these little basins in this area, holding the moisture there longer than the rest of the habitat. And so what we're seeing is that the birds are concentrating in just these little spots to make use of the latent productivity that lasts there just because of the geology of the formation there, that it captures moisture a little bit longer. So in that way, the pattern might look like this, where you have the greening in the of the spring creeping up the mountain, and the drying follows it, but certain areas stay a little bit green. And you can see that drying reduces the availability. So those that stay green, a few larger ponds, they might provide better habitat, and some of them go dry. And so one reason I think this is interesting is you can imagine that with climate change and just the drying extend, like we've been predicted that the drying will extend in Washington because the summer will be hotter and drier. Just that extra week of heat could dry up more of these, so you end up with fewer of these options. But birds like this Nashville warbler fluttering up there to eke out an existence as an alternate strategy to migrating south, this is just what the species does, may put them at a particularly vulnerable situation to manage as we end up with fewer of those wetlands in the mountains, with more of these birds packing into them to try to make the best of a not so great situation. Okay. That's it for the life history scheduling. And I wanted you to get a sense of relevant features of life history issues associated with these molt strategies, this molt life history scheduling that the birds do. So there's lots more to talk there, but that's the main feature that's relevant to bird work in the West that I wanted you to glean from this whole process of learning about molt. The final section that we'll do next is just focused on age and sex differences that you might see in the birds that you're going to be documenting next week. So I'm going to stop here and we'll start that one separately. Stop recording.